In this video, we're going to take a look at static routes and how they're configured. Static routes are special routes that the network administrator manually enters into the router configuration, and we could build an entire network using just static routes. The problem with doing this is that when and not if a network failure does occur, our static routes will not change without us manually performing the change, and that's the primary difference between manual and dynamic. The dynamic routing protocol gets updates, and it makes changes to the routing table as these updates or changes to these updates occurs on the network. When we talk about static routes, we've got to remember that we're going to manually input the information so that the router knows how to route the information from one network to another one. Now, the Cisco IOS provides us with two types of static route statements. The first references a destination address with a local interface and appears in the routing table as connected. That's represented by a C. So we look at the C, and if we look at our menu up above, we can see that the C tells us that it is a directly connected or a connected interface on this router. Since it is seen as connected, it will be automatically redistributed into the routing protocols whose network statements are associated with the destination address in the static route. The second type of static route specifies a next hop address and has an administrative distance of 1. We're going to be talking about administrative distance, dynamic routes, and static routes later on in this series. This route must be manually distributed and updated. So now let's take a look at where we would normally want to use static routes, and later on we'll take a look where we wouldn't. I'm going to bring up a diagram here, and this diagram represents a very simple network where we have two remote locations connected by a WAN link. We have two routers that support two networks that have not been subnetted, and we need to join together these three Class B networks so that each location can share the resources they have at each other's remote office. Let's start by getting the Tucson office access to the remote LAN in New York. We'll need to tell our router in Tucson how to route packets destined for the remote LAN in New York, and we do this by placing a static route entry into the routing table on the router in Tucson. We're going to tell our router in Tucson that if a packet is addressed with the network IP of 204.10.30.0, that's the remote network over in New York, route it to the serial 1 interface on the New York router. And since the New York router has a routing table entry for its directly connected Ethernet 0 interface that matches up with the network portion of the IP of the packet from Tucson, it knows where to route the packet. Now, to make all this happen, we're going to use the IP route command. So I'm going to go ahead and bring back up my terminal here. Let's go ahead and make this minimized. And we're going to bring this up. I want you to look at and take note of the syntax for this command. And you'll notice that we got to provide it with the command IP route. Then I have to provide it with the destination address. In this case, the destination address will be the remote network over in New York, which has the network ID of 204.10.30.0. Next, I have to give it the subnet mask. Since this is not a subnetted network, we can use the default subnet mask. And then all I have to do is tell it where the next hop is, or where the interface is that it needs to send this routed information to. In this case, that's the serial 1 on the New York router. That's all there is to it. So let's go ahead and bring this up a little bit. And now we're going to take us up inside the global configuration mode. Currently, I'm in the privileged executive mode. Now, if I want to make a change to the router that affects the router globally, then I have to be able to go up inside the global configuration mode. Alright, so we're making a global configuration change, so let's type in config T. Alright, currently we're up inside the global configuration mode on the Tucson router. Now, I'm going to tell it to create a static entry up inside this routing table by using the IP route command. Now, if I didn't know what the syntax was, I could just type in IP space ? And I could get the route. But I know that much. But let's say I didn't know what the next portion of this command was to be. There's always context-sensitive help. It says it wants the destination prefix, destination address. It's all the same thing. So now I'm going to type in that address that I want to get to. That's over in New York. So it's 204.10.30.0. Type in a subnet mask. Now, I could have typed in a question mark after I typed in the IP address, but I remember and I know that it needs the complete address. So let's type in a question mark now and let's see what it says. It wants the forwarding router's address. That's the interface of the router that is the next hop. We are connected across this WAN link from serial to serial. And I know that the next hop interface, the next hop router's interface is serial 1. So I'm going to type in 204.10.20.2. Hit enter. That brings me right back up to my global configuration prompt that lets me know that it was complete. Now what if I did not want to have a static route? Just say no. No IP route. Space 204.10.30.0 space the subnet mask. And that will remove the static route from the routing table. Okay, so now if I go back out, I'm going to Control Z out and I'm going to do a show IP route. And now I look and I see that I have a directly connected. Let me go ahead and make this full screen again. I have two directly connected interfaces and a static and one static route entry into my routing table. And this is what's going to tell me or tell the individuals over inside of Tucson, if they need to get something over out of New York's remote network, how to get over to New York to get it. Alright? So that's all there is to it. Now you'll notice that the static entry is up. That's because the interfaces on my router that have to use the static route are up. If the interface for my serial connection goes down, so goes my static route. So if you go in here and you look and you don't see your static route after you've configured it, you might want to take a look and see if your serial interface or whatever interface it is that you're using to connect with is administratively up or administratively down. And you might have to go in and just do a no shut to bring it back up. Once you do that, the static route should be good to go. So we talked about when we want to use a static route. We want to use a static route on a very simple network where we only have one way in, one way out. That works just great. There's no need to waste the bandwidth or the CPU on the router for routing protocols when it's not necessary. You're not going to get anything by using a routing protocol in this instance. If the network goes down, the routing protocol ain't going to have nothing to do with it because there's no other route for it to reconfigure or to update. But in a large enterprise where we have a lot of routers, where we have a lot of networks, where we have a lot of changes being done to our network paths, where the route changes all the time, then yeah, let's use dynamic. There's no use beating ourselves up trying to keep up with the changes statically. Okay? So in the next video, we're going to be taking a look at stub networks, and then later on we'll take a look at default routes, and then later on we're going to take a look at the null zero interface.